Okay, welcome to this video here, and in this one here what we are going to do is the 2010 higher level question B2. Alright, now in this question what we're going to learn, or what we're going to apply, if you're looking at this, is that we need to draw in this curve, and we're going to learn how to use that by the concept of parallel lines remain parallel in every orthographic view, or vertical sections if you're going to a different school and watching this video than where I teach. Right, now we're going to just focus on part A and B. So if this is a homework question I've given you, alright, in 5th year, just part A and B is what you're going to focus on. I'll leave in part C. I'll do part C and D for any leave inserts there who want to do it as well. Alright, now, so the question says the graphic on the right shows a skyscraper, okay, which is located in Miami, Florida. The front face of the building contains a curved recess. Figure B2 shows the outline, elevation and plan of the building. Draw the given plan and elevation of the building. The elevation of the curve may be ignored for this question. Part B. Complete the elevation by drawing the curve on the front face of the building. Part C. Determine the horizontal and vertical traces of the oblique plane that contains the front face of the building. Remember, if you're 5th year, you can ignore this unless I say otherwise. And part D. Determine the true angle between the traces. 5th years can also ignore that. Right. So what I'm going to do with you now is I'm going to do the plan view here. And note that the scale is 1:100, so that means divide everything by 100. Now I'm going to move the visualizer further down the sheet here. Alright, so I'm going to move the visualizer down towards the end here. Right, so note the dimensions, that the angle is 55 degrees. Okay, so I'm going to roughly start maybe, I'd say 70, alright, 80 from the border there. So round about here I'm going to start. So I'm going to draw just a light line across there, and I'm going to pick a point there to start on. Now, the angle is 55 degrees, so we're going to do that with our protractor. So I'm marking that in there. Right, now, the length of this line is, alright, check your book there and see what answer you'll get, 65. So it is. Now, I don't, straight away when I'm doing this, I don't like height-wise on my sheet. It's a bit too high up. So what I'm actually going to do is I'm going to follow this down a little bit, alright, just round about here, and I'm going to mark 65 downwards just for make sure I have enough space on my sheet. Okay, and we can heavy this line in here. Now, I'm going to show you how to draw these sets of lines here, just the angle to get it, and this one here. So 6th years you'll probably know. 5th years, this is something called sliding set squares. It draws in parallel lines and perpendicular lines. So I'm going to line the edge of the set square up against this heavy line here, and I'm going to put another one underneath the long edge of the set square. I'm going to hold down my left hand, and I'm going to slide the set square on my right hand till I get to the tip of the line. And I'm going to draw a light line there. Now, it says it's 100 long, so I've just moved my set square up ever so slightly, and I'm marking in 100 there. And this edge here is perpendicular to the back there. So I'll go through this again. So line one set square up here, put the other set square underneath, hold down this hand here, slide the set square to the dot you want, and draw in the line. You can measure in the line, take away the set square underneath if need be, and then you can line the edge back up here, put another one, or the set square back down there, and slide back to the relevant point. Alright, and we're going to mark in 65 along this line. So I'm going to mark in my 65, and then I have 25 to mark in from this corner. If you look at your book, I'll zoom in there a little bit. Okay, I have 25 to mark in, then I've got 30 to mark in from here. So there should be a little space there. Now, so we'll do our sliding set squares. Line one up here. Slide one down. Okay, this is a heavy line. This is a heavy line. And then this one here, okay, that I'm going to draw in is heavy. And there we go there. Now, trick here is to get the curve in plan, because it doesn't give you a radius. Right, so I want you to have a quick think about how you might try and do it. If you have a circle and a defined radius from any point on the curve to the center is essentially the radius of the circle. So right now in this question we are given a radius of 62 and 2 points on it. So what we're going to do is set our compass to radius 62. So I'm setting my compass to radius 62. And I'll put my compass on the two end points of the curve. Swing an arc there, that's radius 62, that arc. Going to turn it around there. From the other corner, swing an arc, radius 62. And where the arcs intersect is the point you want. So I'm going to put my compass back here. And I'm going to swing there. So, and there's the plan view of it completed. Now, remember, if you have a point in plan, its position in elevation is directly above it. So I'm going to bring all these points from plan straight up. And what I'm going to do is just pause the video there, so when it finishes back here, they'll be brought straight up. And I'll have an XY line in. So what I've done is brought all the points up, and I've put in the height. That's 135 high and an extra 15, so 115 total, and the altitudes. Now, the key here is figuring out which point is which. Alright, so this point here is on the XY line. So there. The next point here, okay, represents this one. So we're going up to an altitude of 150. Okay, and they can be joined together. So I'm going to join them together. Right, now, this goes over a small portion here. So this line here represents this line in plan, that tiny line there. So we're going to do that there now. Right. So I won't be able, you can draw it in your t-square, with your t-square would be the best way, but my t-square will hit off the desk otherwise. I have to move the visualizer. So now I'm going to drop down here 15 millimeters, which is right here. Now this point here is represented by this one here. So we can heavy up to there. Remember, if you have a point in plan, its position in elevation is directly above it. Alright, so I'm going straight across here. Alright, now I'm going to switch to the exam paper over. You're not going to be able to see that really. Okay, so this one is a point in the XY line. This height as it is at an altitude of 150 mil. I can heavy that in. It stretches all the way over. Right, and then this point here represents this line in elevation, and it's a hidden detail line. If you look along the true length of a line, it projects as a point. Alright, so we're two lines in plan. If they represent two surfaces and they intersect, the two surfaces intersect at a corner, there's a line then in elevation. So hidden line over here now. Okay, and then this line here is represented by a hidden line in elevation. Alright, I'm just going to try and fix the camera on the screen. It looks a bit blurry. So it does. Okay, I don't really think that's much better, but anyways. Right, so a hidden detail line here, and then we have part A done. So I can't be definite about how many marks was going for that, but I presume about, let's say 15 I go for that, maximum 15. Right, so our hidden detail line there. Right, now it says do the curve in plan. Alright, so I'm going to push the visualizer a little bit closer. Okay, as I said before, if you have a point in two views, it can always be found in a third. And as I would have mentioned to you, parallel lines are parallel in every orthographic view. So what we're going to do is we're going to draw a set of lines parallel to the edges of the building in plan. So I'm going to just do one there. So this line in plan is represented by this one. And this line in plan is parallel to that one. So this line in elevation has to be parallel to that edge. So I'm just going to bring it up here. And it's parallel here. And look, this is the point. The curve intersects that line. So that's a point in the curve there. So I'll zoom in there. So that's the point in the curve. So I'm going to bring this straight up until it intersects. Now you have to be very accurate doing this question. Otherwise it'll look quite off sort of. Right. So we're going to get started on it. So in plan, we're going to divide up our curve. Okay. Now it doesn't matter the distances you want to go along here, but for argument's sake we'll do it every 10. So 10, 10, 10, 10, 10, 10, 10, 10, and 10. Right. Now, so they don't have to be every 10, but it does make it easier just for simplicity. Now we're going to draw lines parallel to this one. So this line here. So how do you do that again? Line one edge of the set square up against it. Put the other edge right below it. Hold down the bottom set square. So hold down this one. Slide the top one over. And then we're drawing lines parallel. And so on and so forth. So now we need to get these points in elevation. Alright? So it's not a case of going every 10 again here. That's not it. Because those, alright, when you look in this way to elevation, those widths will appear smaller. Alright, so what it's a case of is bringing the points, okay, straight up until they hit the XY line. Right now, so those points there are all represented by this one here. And as I said, parallel lines remain parallel in every view. So all these lines are parallel to that one. So up here, in elevation, all the lines we're going to draw in from the points along the bottom are going to remain parallel to that one. So we're going to apply the same concept here. Okay, so I'll just take away my t-square. So line up your set square, okay, line it up, put one set square below it, so one set square below it, okay, I can't use the zoom function anymore. 1 second here, I'm just going to pause the video. Okay, sorry about that there, and now the zoom feature is returned on the visualizer. Okay, so I'm lining it up here. Okay, you want to be precision here, and now I have a set square underneath there, which I'm going to slide this top one along the lines. Okay. So we're going to do that for each of them. So I'm going to pause the video and do that. Okay, so I've done that. Now, we're going to go back to plan here and realize that the first one here we can call 0. So 0, 1, 1, 2, 2, so on and so forth. 3. So I'll pause again and let you do that. And there I've put in the letters at all. So these are all points in the curve. Now, this is where the logic follows. This point A is on the line 0. So it must be on the line 0 in elevation, and it's going to be directly above. And likewise, point B is on the line number 1 in plan, so it must be on the line number 1 in elevation. So I'm going to take all these points up until they hit the corresponding ones in elevation. So I'm going to bring A straight up until it intersects line 0 in elevation. Now let me just turn off the light on the visualizer to take the glare off there. And there's point A. Alright, and now it's going to go the same with B. So B straight up until it hits the line coming from number 2. Or number 1 rather, number 1, sorry. Okay, so that's B, A. Right, and then I'm going to do the same with the rest of them. So I'm going to bring C up. D up, E up. Now, for speed, if you've done them all symmetrically, E and or D and F are going to be at the same altitude. C and F are going to be at the same altitude. B and F are going to be at the same altitude. And A and H are going to be at the same altitude. So that if you've done them symmetrically every 10, the divisions every 10 down in plan. So that's something just to note if you want to speed up here. So I'm going to zoom out and bring them all up there. H, and then I forgot what you call it, I, so I'm going to bring I up as well. And there's point I. Right. I'm going to pause the video. Okay. Untape your sheet. Alright. Keep your hand neatly inside the curve. Spin your sheet around and sketch in the points. I always like to keep my hand inside the curve, as I was saying. So, for example, I'm just going to do an example on this sheet here. So, I'll go like that. Spin my sheet around. I'll be able to keep my hand in there. That's how I like to do it. And there we go. Now, if you're a 5th year, you doing this question, you can count it that you've that done. If you're a 6th year, just watching this for your leaving cert, alright, to get the HT, okay, follow this line along because it's on the XY line in elevation, so it represents it's on the horizontal plane. So follow this along. Now I'm going to overshoot space-wise on an A3 sheet. I'll follow this one along here. Okay, the XY line along. And this is T, this is H. And the reason this works is because the base of the building is on the XY line. So it has to represent the HT. Now, in order to get the VT, pick any point on the front face, so any point on this portion of the rectangle here. It can't be the second one or the third one because they're not on the front face. That's the top face and that's the back face there, or the back top face, the very far face. Right. So I'm going to pick this one, M, and here's M in elevation. So draw a line parallel to the HT. Okay, continue M on here. I'll just line that up again. So draw a line parallel there through M. Now where M hits the XY line, bring that up vertically. And parallel lines remain parallel in every orthographic view. So they do. So what you call it, this line is parallel to the HT in plan. The HT is along the XY line in elevation. So if you just go straight across from M in elevation, that's a point on your VT. Okay, and then you can extend this on. It hits there, and that's your VT. Now the next part of this question, it says determine the true angles between the traces of the plane, or determine the true angle between the HT and VT. Now in order to do that, you need to see the oblique plane as a true shape. So what we're going to do is take the oblique plane and fold it down until it's flat onto the horizontal plane. So pick any point along what you call it the XY line. The bigger out it goes, the better. Alright, so but we don't have much room here. So I'm going to go around about here. Okay, so there. Alright, we have to now draw a line perpendicular to the HT from there. So I'm going to draw a line perpendicular to the HT there. Okay. And I'm going to continue on there. Okay, I know it's very hard to see this on the desk. Right. Get your compass now. Put your compass on T. Bring the nib out to the point here. Swing it around there. Okay, where it intersects, alright, you join that point of intersection with the arc and the line, back to T, and the true angle is the angle inside there. That's the true angle. So make sure you measure it and write it down. or you could lose up to 8 marks. Alright, so that's the video done, okay, and that's what the solution should look like. Cheers, thank you, bye bye.